Hey guys. Alright, today we're going to take everything we learned in 4.4 and apply it. Okay, which means that we've learned how to write a function from a graph, from a chart or word problem, or to pick information out of an equation, and now we're going to use it for comparison purposes. So just a reminder, if I'm looking at, this is algebraic function right here, it's written as an equation, my rate of change, also known as my slope or my m, all of those things mean the same thing, and it's the 2. My initial value, that's going to be kind of a new word we're throwing in here, is the same thing as my b, same thing as my y-intercept, and it's the same thing as the start. Initial value means starting number, and in that case it's 1. Okay, and if I make a chart over here, let's see. And I calculate our rate of change. Let's see, the y side is counting by 2's, the x side is counting by 1's. So my rate of change is 2 over 1. That divides out to be 2. My initial value, as we're going to be calling it for this lesson, is 1. So that means my equation would be 2x plus 1. And if I had a graph, let's see, this point right here would be my b, 1, but it's also a point I could use. Let me blow this up so it's easier to see. 0, 1, and another point. I mean, we could just use this one right here, 1, 3. Notice those are 0, 1, and 1, 3. 0, 1, and 1, 3. Those are rows in my table as well. Not a coincidence. Okay, so my rate of change my y value went from 1 to 3, so it changed by 2. My x value went from 0 to 1, so that changed by 1. That makes my rate of change 2. And my b is 1, which I think I wrote down already, but I can't see it. I did. I already wrote it down once. So that makes my equation y equals 2x plus 1. What I want to point out is that these are all the same. Okay, you represented the exact same information 3 different ways. Once as an equation, once in a chart, and once in a graph. They're all the same. What you are going to be asked to do today is you're going to be given 2 different functions, but in different formats. So let's say that, you know, somebody was just recording the speed at which a marble rolled down a hill, okay, and comparing it to, say, a heavier marble or a hill that has a different steepness or something along those lines. We would be comparing the path of that marble, the rate of change, how fast is that marble going, maybe they have different starting heights, etc. Okay. In order to compare 2 functions, we need to put them all into algebraic form, so that means y equals mx plus b. Alright, if we're talking about a graph, we're going to look at the change, the slope, and the y-intercept. If we're looking at a table, we're going to look at the rate of change change in y over change in x, and what's the number across from 0. Okay? And we're going to write a y equals mx plus b, or we could also write f of x equals mx plus b, either one. Okay? So function a, here's a comparison question. Function a has a rate of change. Let's see, this side's counting by 2's. This side's counting by 1's. 2 divided by 1 is 2. My initial value is what's across from 0, which is 1. So my equation would be f of x equals 2x plus 1. Now, function b has a rate of change that I don't have to figure out. I don't have to do this fraction division thing. All I have to do is pull the correct number out of the equation. It's 3. And in the initial value, again, I don't have to figure it out. I just have to pull it out of the equation. Okay, now your homework is going to ask you which one is larger or which one is smaller, so read carefully. But for notes purposes, let's just write sentences. Alright, if I were going to write a sentence about this, I would be writing something like comparing rates of change. So I would be looking at the rate of change of 2 and the rate of change of 3. And I could say something like function b has a greater rate of change or I could talk about our initial values. Now they don't have to be, that's a completely separate conversation. All right, you could start off with something, as a higher number and it grows slowly, or something can start off small and grow fast. So the rate of change in the y-intercept, function b had the greater rate of change, and in this case it also happens to have the greater initial value, but it doesn't have to. Okay, function a could have had the greater one. So we could say function b also has the greater initial value. My pen is not working very well. I apologize. Okay, I'm going to fast forward to some of these problems that are actually about something, okay, because this makes more sense then. Okay, Bob heated water in 2 different ways. One way was in the microwave and one way was on the stove to see which way heated up faster. Now guys, we live in the real world. I'm sure you've used a microwave and a stove, and you know that the whole point of a microwave is that it heats up faster. I know you know that. Okay, but we're going to find exact values. So we have 2 numbers in here. We've got 12 and we've got 45. One of them is the rate of change and one of them is the initial value. Well, we need to read the problem. We can't just somehow guess. Alright, 45 has the word per associated with it, which tells me that it is the rate of change. The 12 is talking about the temperature the water started out as. So the context clues of the question tells me that's my initial value, my starting amount. So my equation would be f of x equals 45x plus 12. Now on your homework it asks, this is the first line, but you can't really figure this out until you figure these 2 things out. Okay? So just be aware of that. You're not, even though it'll ask for the equation first on the homework, you're not going to figure them out in that order. Alright, so now we need to do the rate of change for the stove. Well, the stove water is going up by 20 degrees every 1 minute. So that ends up being 20. And across from 0 is 50. So my equation would be f of x equals 20x plus 50. Here's a solid example where if we compare rates of change and initial values, okay, so rate of change here is 45 and here is 20. So clearly the microwave heats up faster than the stove. But the microwave water started colder than the stove water. So the microwave heats the water faster but the stove started out with warmer water. Okay. Okay, I want to do this question and then we're going to end it. We've got corner store, boxes of cereal, and Bargain World cereal prices. Okay, so two different stores are selling their cereal a little bit differently. And it says, part A, determine the cost when a family buys 1, 2, 3, and 4 boxes of cereal and show your work. Okay, so we're going to make a couple of charts here. And in class I did these as vertical charts, but I just decided it's probably easier if I did horizontal ones. They fit better. Okay, so number of boxes and cost. 1, 2, 3, 4. So this is corner store. 1 box of cereal costs $4.50. 2 boxes of cereal cost $9, which makes sense. $4.50, double it, $9. 3 boxes of cereal is $13.50. Again, super makes sense. And 4 boxes is $18. Okay, that's pretty straightforward. Bargain World has a deal going on. Kind of. Doesn't feel like a deal in the beginning. Okay, number of boxes and cost. One, 2, 3, 4. This says that the first box is $6. And each box after that is $3.50. So if I bought 2 boxes, I'd pay $6 plus $3.50 would be $9.50. And then another 3 boxes would be $13. And then a 4th box would be $16.50. I'm just adding $3.50 every time. Okay. Then part B says explain, which means use words and sentences, when a family should buy cereal at corner store and when they should buy cereal at Bargain World. Okay, so English teachers and social studies and science and now math, I'm going to remind you that use the wording of the question. A family should buy cereal at corner store. Okay, and we're going to finish that sentence, but we got to look back at our charts. If you're only buying 1 box of cereal, then at a corner store you'd be paying $4.50, and at Bargain World you'd be paying $6. You definitely would want to pay just the $4.50. If you're buying 2 boxes of cereal, then this would be $9 here, and at Bargain World $9.50, so still cheaper here at Corner Store. But guys, cereal lasts a long time, doesn't spoil. So might look at it as if I buy more boxes, if I buy 3 boxes or 4 boxes, then it's actually cheaper at Bargain World, $13 and $16.50 instead of $13.50 and $18. So if a family should buy cereal at Corner Store if they are only buying, come on marker, that should be 1L, only buying 1 to 2 boxes. If they buy 3 or more, they should choose Bargain World. Okay? Thanks a lot, and I'll see you next time.